Welcome, everyone. Thank you so much for coming out here on the last day of Build. I'm excited to be here. I'm excited to be here with you. And we're bringing this presentation to you today from the future. And by the future, I mean this presentation is subtitled automatically using Microsoft Cognitive Services. You can download an app that will translate it as I speak into the language of your choice. So if you haven't done it already, take a moment, download the application, this QR code, and you can then view everything I say in the language of your choice. And you do that, you just go to the conversation icon in the Microsoft Translator app, you put in the conversation code, which is the top of the screen, select the language you want to view it in, and hit enter. So again, you can view everything I say in the language of your choice as I say it. And if you want to just do it from a web browser, you can do that just straight from the web browser by going to this URL, and then you can see everything I say as I say it. So again, thanks for coming out on this day of Build, and I want to bring to you some exciting information on how you can test your applications for security in the cloud using artificial intelligence from Microsoft. Just as level set, this is a 200-level session. You do not need to be a security expert to get something out of this session. In fact, the whole point of this product is you don't have to be a security expert to scale security testing across your entire organization. It will help if you have background in software development or interest in software development. So I have been really pleased to be here at Build, listening to people throughout the entire time on the show floor. And one thing I've been hearing from everyone is the incredible diversity of things that you, the attendees, build. I've heard from people that build, the order-taking system for major fast food companies. I've heard from people who write code for credit unions that make sure I get paid on time. I've heard from people who are doing fantastic things that push the boundaries of HoloLens. And one thing I keep hearing people over and over again when I ask is, well, I know we need to do secure code. Maybe I'm in a regulated industry like medical, and it's a requirement. Or maybe it's something I just know is a good idea, and I know I need to protect my users, or my business runs on this thing that I'm building. But how do I do it? What do I do? Oh, and by the way, we're moving to Agile and we're shipping every week. So what do I do? So at Microsoft, we've talked about for 15 years the security development lifecycle. And one of the practices we have in the security development lifecycle is something called fuzz testing. How many people here have heard of fuzz testing? Okay, so about half of you. How many people know when fuzz testing was actually discovered? Anyone know the story? Anyone? So this is a fun story. Fuzz testing dates back to a dark and stormy night in Madison, Wisconsin in 1989. So Professor Bart Miller was dialing into the modem pool, back when we had modem pools that you dialed into the one computer you shared with all your friends. And when he dialed into the modem pool, he noticed the line noise caused his applications to crash. And he realized that what nature was doing through nature, he could make his grad students do artificially. So he came back to the lab and said, okay, my grad students, you are going to build a line noise generator, and we're going to throw it at everything we have at Unix on that particular machine. And they published a report called A Robustness Evaluation of Unix Utilities. And they found every single application would just crash if you threw random things at it. Now, you fast forward today, and what we've done is package up the best practices that we've learned at Microsoft, plus some artificial intelligence technology, which I'll show you, into something called Microsoft Security Risk Detection, which we also launched at Ignite as Project Springfield. And what I want to show you today is actual demonstration of the product in the scenarios that make sense to you, of how you can upload your software. You can run a portfolio of different testing methods, which Microsoft continually improves. You can get high-value reports that are updated in real time, and then you can take action. And this is for code that you build yourself, and then you can fix it. It's for code that you're buying, third-party code or open-source code, and then you can fix it or make someone else fix it. And it's for code that's running your business. And this is something that you can have now that packages up an entire decade of Microsoft ingenuity into a service that helps you run this at scale, on demand, through all aspects of your development process. Let me show you what I mean by the artificial intelligence inside of this. Here's a little piece of code. So how many people can sort of see where the bug is, the input that's going to cause a crash here? Just take a minute, and take a look at this. How many people can sort of see what the input is that's going to cause a crash? Hands? Okay. Most people are getting it. Now imagine that you didn't have the source code. Imagine that you had just the binary. And all I did is I said, oh, here's an input good. And I'm telling you there's a bug in here somewhere. But I'm not going to give you the source code. I just give you the binary, I give you Windows Debugger, and I say, oh, where is the issue? So how many people would be able to do that? Just raise your hands. How many people would be able to sort of, just given the binary, given the debugger, try to figure out where this bug is? Okay, so a few people. Now what I do is I go to hacker conventions, I ask that question, and then everyone raises their hand, because that's sort of what they do for a living. But then I ask people, how long does it take? And I get answers that range all the way from like an hour to 45 minutes to 30 minutes. Because what you're doing is you're running the debugger and you're looking at it and you're trying to figure out what is the computer actually doing. And you're saying, well, I can see that the very first thing it does is compare that first byte to B. The second thing it's doing is compare it to A, and then D, and then so on. And then you can use your human brain to say, all right, well, what if I want increased coverage? Well, I should probably try to make that last if statement true, right? That would be something that would increase coverage of this program. And if I want to get to that point, then I have to make the first three if statements the same. They also have to be false. And then that's something that you can reason about, and you can actually get pretty good at reverse engineering. That you can get pretty good at this from a security point of view. And then the challenge is that the people who are really good at that, well, it takes them a while. Even the best people say they can do it in 10 minutes. Mark Russinovich, our CTO of Azure, says it'll take him 5 minutes. What we can do at Microsoft is we can do that in 1/10 of a second. So what we bring to you is a decade of research into automatic reasoning that lets us make that kind of decision in 1/10 of a second. Plus, we have the ability to do a complete time travel trace of your program to support this. And what that time travel trace means, it's kind of like, imagine you had a car crash, and you're trying to figure out what happened. And you see the car's crashed, you see the bumper is dented, you see the wheel is turned, and you're trying to figure out what happened. You know, how many times have you had a bug where like something horrendous happened and you just can't quite figure out what it was? Now imagine you had the ability to go back in time. Imagine a video of the 2 minutes before that car crash. You could step through it frame by frame by frame. That's what our Microsoft technology is able to do for your program. And we put those two things together and we can create a new test case that increases the coverage of this program. Now this test case by itself doesn't find the crash, but that's okay, because we can continue to repeat the process. We can repeat over and over again the same reasoning that you would use to try to increase coverage of this program. And we can create a whole set of new test cases. Well, maybe none of those crash, but you feed them back in, and we can repeat the process over and over and over again until we systematically explore the state space of your code. And in just 2 minutes total, we can find the crash that causes the program to go kaboom. What we have done at Microsoft is we have wrapped up all of this into a cloud service that hides all of this from you. And what we do is we use it to create test labs on demand as you need it in the cloud that fit directly into your workflow. So if you want to test every week or every quarter or every day, that's up to you. It's up to your need, and we can put it all behind an easy-to-use graphic interface that lets you take advantage of this artificial intelligence without having to know very much about how it works. And without further ado, what I'd like to do is show you a demonstration of how that actually works, of the actual product. Now, just a note, all the demos in this talk are recorded, so when you get a chance to download the PowerPoint, you'll be able to download all the videos and look at them at home. They're also recorded to make sure that they can go through even if the conference Wi-Fi has issues. But if you want to see other things, just let me know and we can talk about it after the talk. So when you get access to Microsoft Security Risk Detection, you get access to a web portal that lets you pick a whole bunch of things you want to test. And that's an example of a new job, we call it a job, that you can use to test any piece of software you like. And here I've just created a new job, and I'm getting ready to go in and install my software. So the way it works is we provide a virtual machine to you. It runs Windows. You can install whatever you need to install on it. Today it's a single machine, and here I'm saying this is my first job. I'm going to name it something that's meaningful to me. I could name it with the name of a build. I could name it with the name of a milestone. I could name it with the name of, my team. And I can remote connect directly to that machine in the cloud. And what we've done in the past with customers who have exceptionally complicated things, multi-tier applications, is we've helped them figure out how to fit everything onto one box for testing. So that way you can put everything you need. Maybe you need to install SQL Server or IIS, or you need to install kernel drivers, or you need to install registry keys. The beautiful thing about this is that it's a VM. You deploy it the same way you deploy an AVM. And then we provide a GUI. All you need to do is set up your application, and you need to give us a test harness, just like a test harness you might have written already for doing your functional testing or regression testing. You can go through a GUI, pick up where the test harness is. Here, it's an application called DemoFuzz. And you say, all right, that is the particular command line I want to run that's going to test some aspect of my code. And it's up to you what you want to test. It could be a single library, or it could be an entire application. And then you need to give us a couple of example inputs. So we call these seed files because they're the seeds from which we create a whole bunch of new inputs. Just like you saw on the previous slide, we had that one input good, and we synthesized a whole bunch of new test cases. These are the seeds from which a mighty tree of new inputs will grow. And then we ask you to answer a couple of questions about your application. These are things that you don't have to be a security expert to answer. They're just questions about your code that you wrote. We then validate the job. We make sure that everything that we heard in the wizard is correct. We actually run your program on the simple test case. And then once it's validated, you can push a submit button, and we start going to town. Now, we have a whole other session, which I encourage you to look at, about what's going on under the hood. And you can see our development lead, William Bloom, and and Marina Polishuk working and telling you all about what's going on under the hood. So I won't go into all the details here. But what you can see is that I can go off and do something else. After I push a submit button, I can go back, I can take a look at all the other things I have to test, I can go back to my other work items I'm supposed to be working on. I just don't have to think about it. And what's going on under the hood is that that machine is being prepared to be cloned many, many times to create an entire lab for you on demand, which can run millions of test cases for you without you having to do anything else at all. And what you get is the web portal actually updates in real time. So you see, oh, my job is validating. It's going through a whole process where we're creating the lab for you. We're trying to make sure everything is done properly. If there's any problem, it gets kicked back to you, and you get to notice of what went wrong. And then after a while, we can say, OK, let's take a look at the results. And so there's no results found yet because it's still validating, but then it'll come back. And once it starts fuzzing, that means the entire lab is ready to go. It has the whole thing going. And boom, the lab is ready. It starts fuzzing. And now we can go back and take a look at a real-time updated set of results. So what that means is as the testing is done, in real time, we report to you things that we find that cause crashes. And we actually are able to look inside the crash using Windows Debugger. We're able to look inside the crash and tell you what's serious and what's not. What kind of crash is it? Is it an access violation where you're writing memory that shouldn't be writing to? Is it something that's potentially exploitable that you need to really pay attention to? Or is it something that maybe it's just a breakpoint that got hit? And what we do is we give you this information so that you and your team can set your own criteria for what's important to fix and what's not. We give you the information. We give you the knowledge of the risk so that you can take the action. And we also give you a whole stack trace so you can see where exactly it went. Now, you can download the entire debugger log, but even better, you actually get the test cases that caused the crash. You can actually download the exact same test case that we looked at that causes the crash. And once you have that, you can just reproduce it, or you can attach it to a bug in your Visual Studio and then have someone else reproduce it. And we give you the complete logs as well, everything including the output of the DemoFuzz, everything including the error, and plus some additional information about how it was found. So these are all the logs that you need in order to understand what's happening with a particular application. And you can use that to look at the root cause and figure out how serious the bug is. So here, this is looking at the error that output. There's nothing here, but in your application, you could put some error messages or other things. Here's the complete debugging information. And again, you get the actual test case that causes the crash. So what you see here is you get the information you need to investigate the issue in detail, and we tell you with the little like red caution sign which ones we think are the most important. Now that's what the product looks like on its own, but how does it fit into an actual development team? So when I talk to people here, what I hear a lot is people work in a team, right? Very few people work completely on their own. So how does this fit into a workflow where you have other people, a workflow where you're building every week or every month or every quarter? How does this fit into that whole team workflow? Well, what I want to show you is a customer story talking about how we were able to help a Microsoft customer scale out this kind of testing across all of their teams and how that helped them with one of their customers. So this is a customer story. I'm going to go ahead and play this video here.
Hi, my name is Brian Faber, and I'm the brewmaster of operations for Deschutes Brewery. We know financially we need to be able to take on this investment to build a second brewing production facility. It is a big undertaking, a big financial investment. So it's very important that we're able to really maximize capacity and efficiencies. And so that's when we reached out to OSI Soft.
Project Springfield has really allowed us to test our product in new ways that we haven't been able to before, given the new technology from Microsoft. We'd give a job to Springfield, we'd get the bug report, we'd do our actions based on whatever the report would tell us, and then we'd resubmit the job again and hopefully get 0.
Having a project like Springfield to assure that our data systems are going to be up and reliable and available to us 100% of the time is critical for us to be successful.
So that was when we first launched as Project Springfield. OSI Soft is a middleware vendor that helps people migrate their applications and their data to the cloud. And they helped Deschutes Brewery cut 3 days off of the production time for every batch of beer. So how many people here are writing software for someone else, something that's powering other people's business? So a number of people here are doing that. So this is a case where we helped a Microsoft customer who is a developer first, and they're helping another customer go through the digital transformation of moving their entire business to rely on that software. So we help them identify places of the most need and then run repeatedly this test over and over again. Because as you just saw, we can spin up the lab on demand whenever you need it as part of your security assurance process. And so what I'm going to show you now is a demo of how this might fit into a Visual Studio Team Services workflow. Let's imagine that you have a test plan that says I have to run Microsoft Security Risk Detection. And this is a manual test, but it's something that you can give to your test team or to your security team. And they say, okay, well, there's a new release. I guess I need to test this. And this is something, again, where you don't need to be a security expert to carry out anything you see here. First thing you do is say, all right, I have a new thing I should probably build. Visual Studio Team Services has hosted Build, which is fantastic for creating on-demand builds of your entire application. And so we're just going to go ahead and say, all right, I want to queue a build up. I need to sort of have my application get ready, and I need it to sort of be compiled and dropped on a share where I can use it later. What you're looking at here, by the way, this is a sample application that we'll talk more about today at 1 o'clock in our tech talk. But we are releasing today developer documentation, including sample code. So what you're seeing here is a sample application you can download today, which shows you specific kinds of issues that this solution can find for you. And so you can take a look at that sample code, and you can say, are these the kind of issues that I've seen in my code? Are these the kinds of issues I worry about? And if so, you can use it to figure out, is this something that will work for you and your team? So you can see here that Visual Studio Team Services is doing its job. It is building everything. And then it's going to go ahead and drop the completed build on a share. And I, as a tester who doesn't necessarily know anything about security, I can say, all right, I've got this build. This is our new release. The test plan says I have to do something with it. And what I can do is say, all right, there's the artifacts. That's what I actually need to go and test. And I can say, all right, I have to security test this. Well, what do I do? Well, in the past at Microsoft, what we would tell people to do is say, all right, you have to go security test something. And it's up to you to figure out how to do it. And here's a bunch of things you can download and run on your machine. And maybe you run on your laptop, or maybe you run on the machine under your desk. Well, today, with security risk detection, you don't have to settle for just one machine. You can actually create an entire lab in the cloud, and you can go straight to your build artifacts. So here, you can see that I'm going straight to the actual build for my actual new release. I can download the complete build straight to the machine in the cloud. And then I can use the wizard that we just showed you to actually perform the security testing and get it started. And so one of the things here I just want to note is, like, there aren't any security knobs to turn. There aren't any dials to turn. You don't have to know very much about how security works. That all gets configured centrally for you. And that's a story that we've seen at Microsoft over the last 15 years. Being able to centralize security expertise has allowed our developers to focus on what they do best, which is developing, writing code, building features, getting work items out. And then not on, okay, there's all these 50 million different options, and what do I do? Just to give you an idea, I showed you that, that small example of our artificial intelligence. Well, that's nice. That's really great. And so here are a couple of seed files. These are just like those good things you saw on the slide. Those are some sample files that you might have for your functional testing. And we're just going to go ahead and fill out the forms just like we did before. But one thing I didn't show you, and we have peer-reviewed papers that go into extreme depth in all of this, is that to scale out that technology to something the size of Windows or Office, well, that requires a whole bunch of tuning and tweaking. So does anyone want to guess how many sort of different configuration options our white box fuzzing has? How many people think it's more than 20? Raise your hand. More than 20 configuration options. All right. Now keep your hands up. More than 50. More than 50. Okay. More than 100? More than 100. More than 200? Okay, Patrice, you invented it. you actually don't count, but it's 500. 500 different options, which we take care of for you. And now you can see here, I, as a tester, have been able to take my daily build for my particular release. I've been able to upload it, and I can immediately see crashes. I can see the exact crashes that I can then feed back into a bug, and I can go and assign it to the specific responsible person, and I can tell that responsible person, you know what? Here is a test case. It causes a crash. And you can say, we've agreed as a team that our bug bar is so-and-so, and we don't tell you what that bug bar is, but we give you the information that you can use to set a bug bar. So you can say, this is an important bug. And of course, you can change it based on where you are in a release cycle. And then you can actually take that URL, and your teammates can also be invited to the service. You can share this account between everyone in your entire group, so all of you can collaboratively look at these issues. And then what happens is, if I get that bug, it's assigned to me, it shows up in my queue, I can say, all right, well, all right, I need to download the test case for that particular stack hash. I need to run my calendar reader, which is the application I'm building. And then you'll see here in a minute how you can use that to actually drive the change that you need. So here I'm saving the bug. I've assigned it to the responsible person. In this demo, that's me, because I'm the person working on it. But you could assign it to anyone you like. You can figure out who is responsible for that particular piece of the application, because we give you the exact stack trace. We give you the test case that you need to figure out where it is. And then I'm looking at the bug. I say, I go to this URL. I download these test cases. And you can see that I've downloaded test cases, and they actually give me the actual tests that run. And then what I've done here, just to save us some time, is that I've actually sort of pre-created a command window that has the actual application I'm looking at. So you'll see here in just a second, I've got a command window. I'm just bringing it up. And I've copied those test cases over so I can test them. So again, this is a piece of sample code. You can download it today. You can take a look at it. And you can see how it would fit the kinds of issues you worry about. And boom, the crash reproduces. So it reproduces, and I can debug it. I can bring it up. And then right there in the middle of Visual Studio, I have reproduced the issue. I was saying, oh, there's a read access violation. It's reading memory it shouldn't be reading. And that's something that, based on our knowledge and our experience at Microsoft over the last 10 years, we can tell you that's pretty dangerous. You should take this seriously. And then you can use that to set a complete bug bar for your team. So that's how it fits into like kind of a development life cycle. But now let me talk about something else. So another scenario that we hear a lot from people is third-party code. So how many people here have used open source in their lives? That's everybody. It's just about everybody, right? So at Microsoft, we have a whole process for adopting open source. And we've had this fantastic embracement of open source just in the last 7 years since I've joined Microsoft. But one of the things that we look at, of course, is, well, what is the risk from open source or third-party code? And that can be third-party code that you're licensing in, could be third-party code you see from mergers and acquisitions. And so I want to give a brief story from our customer, DocuSign. And this is something you can also find on our website that talks about this issue. So.
My name is John Easman, and I'm the Senior Director of Software Security at DocuSign. We serve 300,000 companies with 200 million users worldwide, and we're in 188 countries. Security is absolutely critical to everything we do at DocuSign. We build it into every process, and we have to. Modern software development is not simply a question of build versus buy. It's build versus buy and with a bunch of third-party dependencies along with it. And my team have to evaluate whether that component is robust. Microsoft Security Risk Detection ran millions of test cases. Completely automated. There was no additional setup required from us. The results were really positive. My team is constantly looking to automate processes while retaining a good level of coverage. Services like Microsoft Security Risk Detection allow us to do exactly that. I'd certainly recommend Microsoft Security Risk Detection to other companies that are looking for scalable, easy to use, cutting edge technology. I've worked in the security industry for 15 years as a bug hunter. Having this type of technology available to us is hugely beneficial to our team.
So now you've heard the importance of that now from someone whose job it is to protect every developer in his organization. What I want to show you is how I might use our product in order to go after a very common scenario. And that common scenario is downloading a binary from NuGet. So how many people here use the NuGet integration to Visual Studio? Again, just about everybody here. And why not? It's the most convenient way I know of in order to find new software that can accelerate my development, right? If I need a library, it's just right there. So what I'm going to show you now is just a sample of, I'm going to go to NuGet, and I'm going to get a library that will parse an image file format. Maybe I need a JPEG library today. So we're building a calendar. Maybe I need to display calendar information. And I can go and I can download whatever version I want. And some of these versions are a little bit old. And I'm sort of picking on libjpeg because if you actually work in security, and there's no reason you need to know this because most of you don't work in security, I imagine, but you might notice that JPEG has in the past been a source of horrendous security issues, horrendous issues. It's a complicated standard, it's written in C++, it needs to be very fast. So it's a great thing that we could sort of use this kind of solution for. And remember, this solution helps you run millions and millions and millions of test cases all at once. So what I've done is I've gone and written a very simple test harness around it. I wrote something that loads a JPEG from a file, and then it calls some simple libjpeg APIs in order to just do a basic decompression of that file. So again, this is a case where you're not looking at the entire application, but you've identified a specific library that's of risk. And in this case, I might have a JPEG library I'm worried about, and I can go ahead and say, all right, I've tested, my test harness works, it reads a test file. And then the next question is, where do I get these seed files? So in this case, I have a bunch of JPEGs that I've put together, and I need to sort of say, all right, what do I do with that? And I'm creating a package of all of the different test cases and all of the different harness and the thing I downloaded from NuGet. And I can take a bunch of seed files. So for instance, these are files I found just by searching Bing. So if you've been to our sessions on Bing, you know that we have a wonderful search engine which you can use to find images. just happen to go use it to find a bunch of images, and I can just drop those in to security risk detection. I can just copy those over to the VM, and then I can say, all right, I have my drop, which includes my test harness. I have the images, which I got from sort of searching the web. And now all I need to do is run through and set up the entire security testing. So here I am. I have copied everything over. I'm going ahead and making sure I have everything properly done. And you can see I've got this debug thing, and I've got all my debug symbols so I can know when something bad is happening. And then what you're seeing is, after I've copied everything over, I can say, all right, I'm going to extract everything. I'm going to extract it to a directory called CApp, just so I can put everything in the right place. And great, I have my test harness, I've got everything running. And again, we go back to the wizard. So again, there are no security knobs to turn, no security dials to know about. We just put in the application. We can find it using the GUI. And then we just take a bunch of seeds, which in this case I found from the internet, but you could use from whatever functionality or regression testing you have. And you can, in a matter of minutes, just start testing this library. And you fill out this particular questionnaire, which doesn't require you to know anything about security. You just need to say, hey, what sort of, does this run as one process or not? And then just in a matter of minutes, you're testing the application, and it's off into the races. So now it's in security risk detection. You have a whole lab up and running, and boom, you have millions of test cases working for you. So that way, you've seen now how it fits into an entire workflow that you can use with your team. You've seen how you can use it to test third-party code. But the last thing I'm going to show you before we break and sort of talk about what the next steps are and what you can do after you know where the risk is, I want to show you this one more scenario, and something we're actually quite excited about. We know at Microsoft that the world is moving to a cross-platform. We know that people write code for more than just Windows, and something that I hear a lot just talking to people here at Build. I write code for more than just Windows. I need that code to be secure as well. So we're very pleased to announce today is a preview of security risk detection for Linux applications. So if you have Linux, if you're doing any kind of server-side development using Linux, we now have the ability to bring our technology, our scale to you, to bring the same kind of security testing that you saw and heard about for Windows to your Linux applications. I'm just going to show a brief demo of that. So here, you create a job, and then boom, you can ask for Red Hat Linux. And of course, more Linux variants will come over time. And we can say, all right, you now have a new Red Hat job. And just like in the Windows case, we create a machine in the cloud. You can SSH that machine. You can get a password that is long and unique. And you can go straight to that machine and put in everything you want. And in fact, if you saw Scott Guthrie's keynote, you saw that we actually launched an in-the-browser SSH client as part of the Azure portal. So you don't have to download an SSH client. You can do it entirely from the browser. You can actually go straight to the Azure portal and go straight to this machine and then start installing whatever software you need. So in this case, we're installing the software. We're downloading it directly from an Azure Blob Storage. So here we're using Azure Blob Storage as a staging environment where you can take bits from your on-premise, put them onto Azure, and then you can download them from Azure onto security risk detection. And what that means is you don't have to give individual developers the ability to upload whatever they want. You could put it directly into a particular, you could put it directly into a workflow. And I can see the subtitles are obscuring a little bit, but what you're seeing here is we've downloaded something from an Azure Blob Storage, you've put it onto the machine, and then we have a wizard that's command line that's just like the wizard you saw previously. And just like the wizard you saw previously, it doesn't require you to know anything about security. It just asks you a couple of questions about the application itself. So that's something where, let me try to move this around here. All right, sorry everyone. All right. All right. Well, you'll be able to see it when you download the video, but all we've done is fill out a simple questionnaire, pushed enter, and then boom, it's off to the races, and it's off to actually clone an entire fuzzing lab just for you. So. Let's see. So what you've seen here is 3 scenarios. Code you're building, you can use security risk detection to look at code you're building and find issues. Code you're buying or have open source, you can use security risk detection to run millions of test cases. And if you're taking code that is legacy and you're using it to build something for the cloud, this is an opportunity to run millions and millions of test cases with the best technology we have. Battle-tested technology that's been used at Microsoft for over a decade, plus the artificial intelligence I showed you for finding crashes. This is something that you can use to figure out where the risk is in your code. Now, the question is, once you have the risk, once you know where the risk is, what do you do next? We're very pleased to be bringing this to market with Microsoft Premier support for developers. So if you're interested in Premier support for developers, we actually have Pablo and Joe here in the audience from the Premier HQ who can answer all of your questions. There's also a booth on the hub floor, which I encourage you to go to. And that you can learn more about all the different offerings Microsoft has to help your development teams build faster. All the proactive trainings, all the security code assessments, all the things Microsoft has that can work in tandem with this solution to help you build more secure code faster and let you get back to focusing on what you love, which is writing code, and less of what you don't love, which is waiting around for a security person like me to tell you you're doing it wrong. We are also very pleased to be working with partners. So some of you may have seen Ernst & Young and Leviathan on the show floor yesterday. So these are cases where if you or your organization want some additional help or additional guidance on how to put this into an entire workflow, we're very pleased to be working with these 2 partners who have extensive experience in working with large organizations and also extensive experience in particular technical use cases like running embedded systems or on top of on doing security. And then you can actually learn more at Microsoft Build. We have even more content to help you out. So I've talked to you about where you can go for next steps with Premier support and our partners. But we also have additional content that you can use to learn more about the solution. So we have a pre-recorded session where we have Marina and William from the team. And we actually have many of the team members here. So people from the team, please raise your hands. All right, so we have team members here who can answer all your questions about the service and how it's built. And we have a pre-recorded session that goes under the hood to show you a little bit more about how we actually use Azure to scale out this service for you. And then we have a deep dive on the actual test code that you saw. And we actually compare the issues we find to issues you can find with Visual Studio's static analysis, if you're familiar with that. We show you things that this solution can find that the Visual Studio static analysis isn't yet able to find. And we go into more detail about some of the things you can do as a Microsoft developer to contain this risk. For example, Windows 10 Creators Update actually includes a number of features that you can use today to sandbox code, even if you're not able to change it. And so we talk about that in the How to Fuzz It session. We have an overall session for artificial intelligence that helps you become an artificial intelligence developer. And then we have a session on the Bing API, which you can use to understand how you could use Bing in conjunction with a solution like this. And then finally, if you want to deep dive into the actual sample application, if you want to see some real bugs and see how they get found and how they get fixed, I encourage you to go to the Tech Talk at 1:20 p.m. That's over in Tech Talk A on the hub floor, where Dave Tomasi from our team will be actually challenging the audience to say, what's your favorite kind of bug, and showing you how the solution can find it in real time. So our call to action, first of all, please sign up. We have a URL. If you want to be the first to get access to this, sign up here, give us your information, and we will contact you and help you figure out how to get a preview, how to get on board, how to get it to be deployed across your entire organization. We have a hub station, so does Premier Support for Developers. You can come and learn more about how you can use this solution to fit into your workflow and transform your team so you can spend more time writing code and less time worrying about security. Members of the team are here. Members of Premier Support for Developers are here. You can come meet us. All our questions, we're here for all your questions right here after the session. And then finally, we actually have, as I said, documentation and sample code. So you can see the kinds of things this finds. You can download an application. You can try it out for yourself and see how it fits into your workflow right here at the Dev Center. So with that, I'd like to sort of break for time, and then I encourage you all to come meet us all after the session and ask all the questions you like. Thank you very much.